Okay, great. Well, certainly I'll try to speak up too. Thanks everyone for coming this afternoon. I appreciate you attending. Hopefully this will be interesting and useful to you. I know that the agenda calls this something about revolutionizing social services delivery and stuff like that. I'll let you all be the judge on just how revolutionary this is, but really the heart of the conversation is about building a large-scale Corticon implementation, scaling it up to service multiple applications and making into a shared services platform. So I don't want to deflate any expectations, but revolutionary is such a loaded word. So I want to kind of tamp down your enthusiasm a little bit. All right. So here's the agenda that we're going to cover today. I'm going to give you a brief introduction and overview of this Maryland Think project or program. And then we're going to talk more about sort of from a Corticon perspective, what we do to operate, to implement, even to design at that scale. Literally a platform to service an entire state worth of citizens and beneficiaries. So we'll kind of step through a lot of the topics here. What goes into the architecture and design, development testing, even some of the gory details like source control and DevOps, talk a little bit about performance, and also the role of the Corticon Center of Excellence, which really only typically gets used in the very largest of projects. Most projects don't have the luxury of dedicated centers of excellence. Fortunately, this one does. That's part of my role on the project. And then finally, I really do hope to speak fast enough so that there's time for a Q&A at the very end. Okay. So before I tell you who I am, let me just do a quick pulse on the room here. Who knows what a BRMS is? Okay, couple. Who here has ever seen Corticon used before? Even demos count. This guy right here does a lot of demos, so if you've seen one of his demos, then that counts. Harold does demos too, that counts. So people have seen Corticon mostly. Are there any actually Corticon users or customers in here? All right, just one, is that it? Only one Corticon customer? Who's here because they heard there were going to be free cupcakes at the end? All right, so this presentation really isn't an introduction to BRMSs or Corticon. I happily refer you to the capable hands of Seth and Harold for that type of thing. This session is really going to be most relevant to you if you already have a Corticon implementation and you're looking to scale it up or you're looking to expand it in order to serve multiple applications or migrate to a shared services platform. Can you hear me okay? Okay. But hopefully you'll still find it interesting even if you don't fit into any of those categories. At least I'll try to make it interesting for you. And there are no cupcakes, sorry. So hopefully you'll stick around, but if you don't, I will understand. All right, a little bit about me. In a nutshell, I've been part of the Corticon ecosystem now for about 19 years. I'm as an employee, as a practitioner, and as a true believer. Maybe one of the very oldest true believers around, even older than Harold, and that's pretty old. Because, quite honestly, as a problem solver, it's really great to have a tool that you can trust to solve problems. And Corticon is one of those tools that you come across once in a while that does exactly what it says it will do, and that is to solve problems that involve business rules. So it's a lot of fun, frankly, to be involved in this space and to do projects like I'm going to describe to you today. All right, so I'm just assuming you know nothing about the Maryland Think project, but I'm still going to give you a quiz, and I bet you all will pass it. Okay, so the question is, why is Maryland spending $250 million to modernize its social services applications? Answer A, because spending that much money and being subject to state, federal oversight all the way up to the governor's office and the legislature and federal agencies is a lot of fun. We really enjoy this. Answer B, but you can wait, by the way, to the answers to vote. All right. Answer B is because the legacy systems that are being modernized, that are being replaced by this initiative, are too slow. They simply don't perform well anymore. All right. And your last choice is existing legacy systems just are no longer capable of change. They're no longer capable of evolving to meet the changing needs of the business in a cost-effective manner. All right. All right, so now let's take a vote. Who thinks the answer is A? Good. Who thinks the answer is B? Good. So it's unanimous for C? All right, good, you're all right. So let's take a look at these answers here. So answer A is obviously a weak attempt at humor on my part. This is really no fun at all. Nobody wants to do this. From the CTO on down, nobody enjoys this part of it. It's necessity. It's when you're spending that kind of money, though, it really is a necessity you can't avoid. Answer B is simply false. It's not true. Okay, one of the things about mainframe-based legacy systems is they're almost always well-performing. They're almost always fast. They're almost never obsolete because they're too slow or because they no longer perform. There's other reasons for their obsolescence. And that really boils down to answer C. And recognizing that this is the reason for spending $250 million of taxpayer money, recognizing that this is the reason why we're doing it is key, not only to understanding why our BRMS is even being used in this platform, but it also guides us in how we apply that technology, how we apply that tool, how we use Corticon, not only to solve this problem today, but to make sure this problem doesn't occur in a few years. This is kind of my definition of legacy. All right, legacy doesn't just mean old. Legacy really means that it's no longer capable of evolving. And I've seen 5-year-old systems that are considered legacy by their users and by their owners. And the reason why is because they no longer are able to change because they were not designed to change in the first place. So with that in mind, when we look at a new initiative like Maryland Think, large initiative, we were looking at through the lens of BRMS. We really want to build an application or a platform that resists becoming legacy, that stays changeable, that is able to evolve over time. So our eye is as much to the future maintenance of our application as it is to the current design and implementation of that application. So this presentation is really about how we do this, and how we do this at a scale like Maryland, where we're working with dozens of applications that are all using, to some degree, Corticon. All right, so now that I've quizzed you on what Maryland Think is, let me tell you a little bit about it here. These next couple of slides are state slides, so that's why I've changed the formatting and the branding here. These are Maryland slides. There are a lot of acronyms here because, it's the government. But the sponsor of the Maryland Think project is the Department of Human Services. Multi-billion-dollar budget being spent on every imaginable kind of benefit. And the various applications that are being developed and being deployed sort of fall into 3 general categories. The one on the far left here, this Family Investment Agency, this is sort of the standard state benefits eligibility type programs. Things like Medicaid, things like the Affordable Care Act, Obamacare, health insurance underwriting, things like food stamps, which they call SNAP, things like welfare, which is really called TANF, and long-term care. So these are the kinds of applications that kind of fall into the eligibility category. There are also applications that fall more into a compliance category, where you want to make sure that all the participants in the process are following the rules. And a good example of that is child support. That's currently where my team is working at the moment. But the bottom line is you're just making sure that non-custodial parents who are paying child support, who should be paying child support, are actually doing it. And when that money gets paid, it gets distributed to the right parties. So on the one hand, you've got some very large and very expensive programs like long-term care. Long-term care has about 20,000 participants in the state of Maryland, and the average annual benefit is about $60,000 per person. enormously expensive on a per person basis, an enormously expensive benefit. As anybody who has a parent or a grandparent in a long-term care facility or a nursing home knows, the costs associated with that are tremendous. So we started with long-term care just because the mistakes are really expensive in that program. You give people eligibility for programs that they're not eligible for. It costs the state a lot of money. On the other hand, child support, an important program in the sense that we want to make sure that children get the support that they have coming to them, but it costs the state virtually nothing because all it really is an intermediary role where they're essentially shifting money from one parent to a child. It doesn't cost the state very much at all, but it's still a really important application as a state benefit. Okay. Drilling down a layer here, the CTO at DHS calls this his layer cake architectural diagram, where the any Sitefinity guys in here? No, okay, so we can make fun of the front end, right? All the frosting, right? All the fluffy stuff is on the top, the user interface, stuff like that is all up here. Mobile applications, that's all up here on the top. Down here is the chewy data layer. And in the middle are services. And here's where Corticon lives. Big, nice blue block, shared service, eligibility determination business rules for all these acronyms, Obamacare, food stamps, welfare, more as refugee assistance, long-term care, et cetera, et cetera, et cetera. So this is the goal. And I want to point out a few things about this that aren't really clear. Oh, also, by the way, all the stuff on the side here, these are all interfaces with other various government systems, state and federal systems. I don't really know how that fits into the cake analogy, but that's what the purple is. So everything here is either on Amazon EC2 or in the process of being put on Amazon EC2. So some of the unusual aspects of this architecture are it's cloud first. Everything going to the cloud is being built specifically for the cloud. We're not migrating any existing applications. The existing applications are being left behind. So we're building everything to go to the cloud first, specifically Amazon. Secondly, we're using a lot of open source software. Of the $250 million budget for this program, only about $9 to $10 million of that is actually being spent on software. So a really small fraction. Of that, a good chunk of that is actually being spent on Corticon. That's, number one, that's how important that the state of Maryland sees Corticon, that they're willing to not only pay for it when they're getting a lot of other stuff for free, but they're actually willing to spend a lot of their budget, relatively speaking, on Corticon. And finally, this is a true shared services model being designed that way from the beginning. The applications that I showed you on the previous page, that's just the beginning. That's just the Department of Human Services. They're the ones sponsoring the development of the platform, so they get to go first. But there's taxation, there's licensing, there's a whole number of other state agencies that are already getting in line, waiting to migrate their applications or modernize their applications onto this platform and take advantage of all these services that you see here in blue, including especially Corticon. I should say Department of Education also, one of them. So when you factor in the size and the scope and all these other aspects, there's actually a lot of risk here. I think by any standards, there's a lot of risk here, and certainly by government standards, certainly by state standards. Pretty unusual in my experience to see a state CTO willing to bite off this much new in one bite. One of the reasons why I think this has been a fun project for those of us involved because the CTO is willing to take this kind of risk. So drilling down a little bit further, let's talk Corticon. That's why you're here. This is how we're deploying Corticon Server as a real enterprise-wide service, as a layer in the architecture, so to speak. We see a lot of implementations where Corticon Server is sort of embedded in the application that it's serving. And that's fine if that's the only application that you care about. There's nothing wrong with that. But if the goal is a true shared services model, well, Corticon is one of those important services that you want to share. So what we've done instead is we've installed Corticon Server on dedicated hosts, dedicated web servers that all applications in that layer cake architecture can access via a common set of APIs. In our case, we're using REST, but SOAP also works well and allows you to deploy in a centralized fashion like this. And then if you think of, so let me point out a few pieces here. So here's the frosting up here, the web UIs. Here's the application layer. Here's the API layer. Corticon Server is living out on EC2 along with everything else behind a load balancer and ELB. And then what we have behind that is really just an inventory of decisions. Some of these decisions apply specifically to, say, Medicaid. Some of them apply to child support, et cetera. But they all live together in the same place, and they're all managed and controlled in the same way. So in order for us to scale this up, in order for us to add more decisions, we simply add to this inventory. The applications that are live right now include long-term care, and ACA is the technical term for Obamacare, but it's the health insurance portal for the state. All these other applications are currently in various phases of development, and we know that as these decisions get created and built, we literally just add them to this inventory. Now, we do have dedicated development environments for each of the applications, because in development, your environments are up and down and changing all the time, and you don't want to mess up the Medicaid team because you're taking your development environment down for food stamps. So while we do have dedicated development environments, all the environments above that, from UAT to staging to prod, they all look like this. They're all shared, they're all deployed together, and they're all scaled together. I'll point out also down here in the corner, Corticon Server is being deployed into Dockerized Tomcats. So we need more capacity, we just spin up another Docker. It's easy as that. And along with that instance comes the entire inventory of decision services. So what happens, the eligibility for these various applications run different times of the year. They have their own different cycles and their own different frequencies. So long-term care, for example, a lot of stuff happens there at the end of a month, whereas ACA or Obamacare happens during open enrollment period during the year, which happens, it's coming up in November timeframe. So the capacity can be served really well when we're all sharing these resources. And if November rolls around, we anticipate open enrollment coming up for ACA, we'll just spin up a couple more Dockers with Corticon with this inventory of decisions, and suddenly these decisions get consumed a lot more frequently during the production. These other ones just sit there. They may not get any additional utilization. They may just sit there unused. Who cares? We can just spin up and spin down these Dockers as we need, and the load balancer will take care of making sure the requests get where they need to go. All right, a little bit about design, and then we'll kind of roll right into development. But in design, looking ahead at all the applications that we know we're going to build, what can we do as Corticon developers to prepare for that? Well, probably the single most important thing we can do is to work towards a common vocabulary. For those of you who know Corticon, you already know what I'm talking about. For those of you who are not so familiar with Corticon, you can think of the vocabulary as being an object model or a data model. And it's the data model or the foundation that we build our rules on or from. We want an abstraction. We are using an abstracted model that is actually shared by a lot of different components in the application. The front end shares the model. Obviously, the rules share the model, and the integration layer shares the model. So we're piggybacking on that model, and we're staying common to that. It's not a highly normalized model. Any DBAs in here? Okay, good. No, you're a DBA? All right, so it's no Boyce Cod, no fourth form normal, nothing like that, okay? Business object-oriented, friendly. Friendly to people besides DBAs, humans, right? No. Now, definitely takes more effort to do this. I won't lie to you. It takes more technical effort to do the analysis, to figure out what things are truly common, and what things can be reused. But it also takes a lot of political effort. There's a lot more consensus building. Seems like we spend more time building consensus than we do building software, but that's what happens when you're dealing with large projects. And maintaining the discipline, right? Under the pressures of development timelines, sometimes it's really easy for a team to just go do what they need to do to get it done, right? But keeping them on the path for a common vocabulary is important, because once you make that decision to fork or to branch your vocabulary, it's really a one-way street. You really don't get any second chance to go back and refactor later on. But we think that it's worth it. To give you an example, already within the different teams building rules at MD Think, the Medicaid team is already reusing about 70% of the rules from the long-term care team. And the food stamps team, the SNAP team, is using about 30%, or reusing about 30% of the rules from the Medicaid team. Now, food stamps and Medicaid, nothing in common, very little in common. That's not true. There is obviously some commonality, otherwise we couldn't reuse our rules. But if we didn't have a common vocabulary, we'd have no chance, we'd have no prayer of reusing our rules. And it's not just the rules that benefit either. If you're building rules on a common vocabulary, then the APIs that access those rules tend to be more common, which means the team building the APIs has less customization to do. They can reuse more code. They have less retesting to do. Everybody wins. But it is tough to maintain the discipline necessary to stay common for very long. Like I said, the pressures to just get stuff done, get stuff into production can be hard to resist sometimes. But like I said, once the project is over, there's very rarely budget, resources, energy, appetite to go back and refactor things that you just put live. So the way we see it is we really only get one opportunity at this. Once the window's closed, you've lost it. Also easier to train. So when we're moving people around from project to project, our rules teams tend to be pretty small. There's about 500 people in the project altogether. Only about 8 or 9 of them are involved with Corticon development. So any one of those applications may only have 1 or 2 or 3 developers working on them at one time. So we'll flex our teams. And when we have a common vocabulary, it makes it a lot easier for developers to jump in and jump out of projects that are already oriented, that are already familiar with the foundation that we're building our rules from. And like I said, it takes discipline, and that's one of the things that the Center of Excellence does, is we try to maintain that discipline. So when someone says they've got a new need, we validate that the need really is new and it can't be addressed in an existing way. If needs truly do need to be designed, we want to make sure it gets done smartly. And of course, if we add or delete things, we want to make sure we're not breaking any of the other applications that are involved. And if it comes time to branch, there will be some times that are just good reasons to branch, right? Legitimate technical reasons to branch. But we say when. We say if. Sure, Harold, go ahead.
Is the team allowed to prevent transients attributes?
No, we actually keep pretty close control on the vocabulary. The Center of Excellence keeps pretty close control on the vocabulary. So while we don't really worry too much about transients, by the way, for those of you who are not familiar with Corticon, you can think of transients as being temporary elements or temporary fields in the vocabulary, things that will not be persisted, things that will not be part of the integration or the APIs. So in other words, there are things that are really local to Corticon. And so we can add them and remove them without hurting or impacting anybody else. So to answer your question, Harold, we typically don't worry about those too much because, like I said, they don't impact anybody, but we do still control it. Nobody is able to just willy-nilly make changes to the vocabulary. Similar to a DBA doesn't allow people making changes to the schema willy-nilly, right? In fact, never, right? Yeah. Without a lot of pain. I always look for somebody in the audience to bond with, and I can tell we're already, All right. All right, so let's get into, oh, wait. No, I'm ahead of myself. Sorry. Next slide. Patterns. Did you guys see Dimitri's opening talk this morning, his keynote? He showed the periodic table of the elements with the crazy-looking guy. Mendeleev is his name. And his genius was to look at a bunch of elements, metals, minerals, just a bunch of stuff. His genius was to look at all that and make sense of it. His genius was to be able to sort that into categories, organize it in a way that informs us about the elements, tells us more information, like a biologist classifying living things. The effort to organize, the effort to classify it has value in itself because it helps us understand the groups and it helps us understand how those things relate to the things around them. In the case of the periodic table, it also has a predictive element because you can kind of expect that the next element happens to be in this group. It's going to have certain characteristics based on that group, right? So I don't want to oversell this analogy, but the process of looking at our business rules and trying to find patterns is really key. Patterns that we can use. Yeah, patterns that we can use not only to organize our rules, but also help to express them as clearly as possible. Clarity of expression is such an important thing with business rules, right? Again, think back to our goal of preventing or delaying as much as possible the onset of legacy. It's like the onset of Alzheimer's, right? We can't prevent it forever, but we want to delay it for as long as possible. Designing for clarity of rule expression, organizing our rules is really important. And patterns, detecting patterns, implementing patterns, organizing our rules around these patterns is really a key part of that. And we look for patterns both logically, common similarities in the way the logic of the rules work, but also visually, which really has nothing at all to do with the logic, but it is helpful to the humans. We'll come back to that in a few minutes. And also, there are tools within Corticon Studio, which is the design environment or the development environment where we build our rules. There are tools built into Studio that need patterns to work properly. If you've seen a Corticon demo, you may be familiar with the conflict checker and the completeness checker and some of these tools that help us get our rules right. Those tools, as valuable as they are and powerful as they are, to some degree depend on us as rule modelers to identify the patterns in advance. If we don't put all the rules that share the same pattern together at the same time, the conflict checker is not going to be able to give you full and complete information. So another reason to do the analysis necessary to identify the patterns and organize around them. Another reason for patterns is modularity. We want modularity for a couple of reasons. One reason is it actually supports clarity. Creating categories, creating modules of rules actually helps us to organize things and make them more clearer and easier to understand. It also helps us from a technical standpoint for reusability. And I'll show you an example of that in a moment. If we have these modules, it makes it easier for us to reuse the modules across different applications, which we do a lot of at Maryland. And it also helps us to isolate. And when we can isolate something, we can control its introduction into the application or its withdrawal from the application. We can also isolate it for purposes of troubleshooting and figuring out what's going wrong. Rather than having to troubleshoot the entire application, we want to be able to isolate it to just those parts that we think are impact. Corticon, fortunately, makes modularity very easy. We take advantage of a lot of the things that Corticon lets us do to define really high and varying degrees of modularity. I'll show you some examples here in just a moment, because this is this is kind of the art of Corticon, rather than the science. So now let's segue over here into development and testing and talk more about the science. All right, so I already mentioned that clarity is really our first goal, actually our first goal is getting rules to work, okay? I don't want to get ahead of myself. The first thing is they got to do the job, right? They got to solve the problem. But after that, in a close second, is making sure that they're organized clearly as possible, so that long after I'm gone, my replacements, will be able to continue to maintain this application. One of the really important things we use is Corticon's features for making our rules transparent and allowing our rules to generate feedback. I'm going to give you, rather than talk a whole lot about this, I'm going to show you some examples of it instead. It's easier when you see it. Already talked about modularity. I'll show you some examples of that. Data marshaling, we'll talk a little bit about that. Anybody who was in earlier and saw either Harold's REST talk or Jim and Seth's talk about batch processing at the state of Ohio. This sort of dovetails a little bit into those two discussions because rules need data. You can't make a decision if you don't have data, and so a lot of what we do in Corticon is figuring out what data do we need and how do we get that data into our rules. So we'll talk a little bit about that. And then the bottom one, it really shouldn't be at the bottom because one of my favorite topics and it's one of the most important things is the importance of testing. I know that sounds like gospel to anybody who's ever done anything in IT, but Corticon gives us some really powerful tools. And the bigger your implementation becomes, the more expansive your implementation becomes, I think it becomes more important to take advantage of these tools. So I want to show you specifically how we take advantage of these tools at Maryland that really, really help us. This is something that I think I appreciate more as time goes on. There are some features in Corticon, they've always been cool. I think they were cool from day one. But this is a feature that I think I only appreciate more with projects like this, where if you didn't have something like this, you'd be in trouble. All right, so let me talk about patterns here. Here's an example of a logical pattern. This rule sheet, by the way, really quick orientation for Corticon. In Corticon, you're basically using a decision table to model your business rules. And in the decision table, we have a series of conditions in this kind of quadrant of the table, and we have a series of actions in this quadrant, and then these columns that go from column 1 on off into the right there. Those columns are simply combinations of specific conditions and specific actions. So the column that I have highlighted here is column number 2. This is a rule sheet that focuses purely on citizenship determination. There's only about a half a dozen rules here. I'm not really hiding much from you at all. If you scroll off to the right there's really nothing there. There's only like a few rules. So, but I've organized all my citizenship rules into a single rule sheet. So if I have a change to a citizenship rule, I know where to go. I want to add something, I know where to go. And here is an example of a pattern. Rule number 1, 2, and 3 all share these top 3 conditions. I'm looking at the citizenship status. I'm looking at the customs and immigration status, if they're visa holders, if they're not naturalized or native-born Americans. And I'm also looking to see if they've been a lawful resident in this country for a 5-year period. So those 3 conditions, all I've done is created different combinations of those conditions. And if any of those combinations, let's see, if I'm an alien but I'm a student diplomat, didn't know that was a category, did you? If you're an alien but you're a student diplomat, or if you're a temporary resident, then no, you don't have valid citizenship. Right? Really, really simple rule. I'm not trying to complicate things here. This rule right here, rule number 2 and rule number 3, are similar in the sense that they share the same pattern. So, this is the kind of thing we look for. Make sure they're all put in the same place. Make sure they're all expressed. We want this pattern to jump off the page. For someone who looks at this rule sheet in a year and has no documentation and no no turnover. We want them to look at this rule sheet and say, I see what's happening here. These are just various ways of determining citizenship. And if there's any question about it, we also provide rule statements down here at the bottom. This is something that Corticon doesn't force us to do. These rule statements. Yeah, all the documentation, tutorials, they all do it, right? But there's nobody holding a gun to your head saying, thou shalt add rule statements. But as I'm going to show you in a few minutes, this is really critically important. And the bigger your project gets, the more complicated your project gets, the more important this becomes. I still have time, right? Yeah, okay. All right, so I'm gonna keep going here and get to the examples. Here's another example, or here's an example of well, there's a couple of things going on here. One is, this is really an example for modularity, because I want to show how if we organize by modules, it makes our job to reuse our rules even easier. On the left-hand side, what you're seeing here is what Corticon calls a rule flow. This is a rule flow here, and this is another rule flow. You don't see them like this in Corticon. I've cut and pasted two different screenshots. So we're looking at two different rule flows at the same time. Each rule flow is its own separate decision service, which gets consumed by the application at different points in time. The purpose of the slide is really just to show you how, by organizing our rules as modules, we get maximum reuse. So here is the long-term care decision for adults, and here is the long-term care decision for children. It's a sad fact that there are children, unfortunately, who are institutionalized because of birth defects or whatever. So we have special programs for them to make sure they get the care they need. And the rules are different, but a lot of the rules are the same. So the blue boxes, this is just kind of our arbitrary color code that we use. The blue boxes are reusable modules. We have modules here that deal with financial rules and non-financial rules and asset rules and citizenship and things like that we use generically across both decisions. The only thing that's different, the only thing that varies from these two different decision services are the green boxes. We have a few special rules here for adults and a few special rules here for children. So this is probably an example of maximum overlap, maximum reuse. The Medicaid rules look like this, but there are fewer blue boxes and more green boxes. Whereas the food stamp rules, even more green, even less blue. But if we don't go to the point, if we don't go to the effort of doing the analysis, then everything is green. Nothing is reusable. The other thing this is an example of is a pattern. Right? Just the visual pattern, the way we've color-coded things, the way we've laid them out on the screen, because it looks like this no matter which application you go to. If you drill into the boxes, you'll see differences. But someone can take a look at these rules who's familiar with food stamps, jump right over to Medicaid and say, I understand what I'm looking at. I see how things are organized. It looks a lot like food stamps does. And we save a lot of time in cross-training and bringing new, onboarding new resources. It's a 4-year project, so you will have turnover. You will be onboarding new resources and losing people. So patterns are one way to make that turnover process as easy as possible. Okay, modularity for isolation. I mentioned that we use modularity as a way of sort of onboarding new features as well as offboarding new features. This particular module is what we call a feature in waiting. It's been tested, it's been developed, it's been tested, and then it's been disabled. The fact that it's gray here in the rule sheet means that it's not active. Those rules that are inside that rule sheet don't execute. They're just sitting there. Because at some point in time, somebody is going to make a decision. It's time to turn that feature on. And there may be a lot of dependencies behind this, right? There may be technical as well as human dependencies. Caseworkers have to get trained. Legal notices have to be sent out to recipients. So whenever that time comes, in order for us to sort of activate this feature, we can just enable that rule sheet. It's already been tested, and we activate this rule sheet and redeploy our decision service, and boom, that feature is now in production. We can also do the opposite. If we want to deprecate a feature, we can disable it, We always leave it disabled. We let it sit there for a while. We let it ferment a little bit because sometimes the users come back to us and say, you know that feature that we told you to get rid of? We changed our mind. We give it to us back. So if we let it sit there for a while, what do? We just re-enable it. Pretty easy. Pretty easy to take things in and out of production that way if you design for modularity. Okay. Oh, geez. Do I really only have 4 minutes left? What time did we start? 3:45, right? Yeah. Okay. I really only have 4 minutes left. Okay. I'm going to skip marshaling data and I want to talk about test suite development because, like I said, this is really important and it's something that becomes more important the larger your implementation becomes. Modularity applies here too. So for every module of rules that you build, you want to have a module of tests. And the more rules you get, the more modules you get, the more tests you get. Eventually, you're going to create a really large test suite. In long-term care, we have over 1,000 test cases that are that handle very specific business scenarios. And we use these every day. Every time we make a change to our rules, we have this wonderful test suite, comprehensive suite that we can use to make sure, A, the new feature works, and B, we haven't broken anything else along the way. And we also capture all of our transaction data in a database. So every request message being sent to Corticon is being persisted in a database so that we can always go back and recreate exactly what the rules saw and exactly what the rules did at any point in time. It also makes a great way to troubleshoot and add to our test suite. So over time, our test suite's gotten really big. Here's a big test case, okay? And the goal here is not to overwhelm you with words, but this represents in Corticon Studio's test bench or tester facility. This is basically data. This is a tree view of our data, case data. You can see we've got household members and incomes and institutions. These are long-term care facilities and stuff like that. And so this is all input, and this is our output. And so in other words, this is the output the rules have created. If you see something in bold, that's a value that the rules have somehow touched, updated, or created. And over here on the far right-hand side is the expectations that we have as testers. So this is what we hope to get. This is what we actually got. And one of the cool things about Studio is it automatically compares the two. In this case, what we hoped to get for this particular field called personal needs allowance was $80, and we actually got $78. So Corticon highlights that for us in red. But we can automate all this. The APIs are available. We can put these in scripts, and everything that you see in Studio can be done in an automated fashion, which when you have 1,000 test cases, you pretty much need to do. So whenever we put something into production, we can run our huge test suite. We can automatically pluck out any differences like this because it's made available to us by an API, and we can report on it. So before we deploy any new feature, we can see exactly what has changed, and we better understand why it changed. And in some cases we don't. We have to investigate to see what happened in order to make sure that it's working properly. All right, and this sheet right here, again, unfortunately it's probably too small to actually read, but what I've done is I've taken the bottom of the rule sheet and I've moved the window all the way up. So what you're seeing here is sort of hidden in the previous sheet. But this is some of the most important thing that Corticon Studio does for us is the rules have these rule statements at the bottom, and if we generate messages, if we quote unquote post the rule statement, we get a message for every single rule that fires. And in an eligibility decision like long-term care, we get about 400 rules out of 1,000 that fire. And when you generate rule statements like this, it tells us the entire story of the transaction. Not only do we have the raw data, which for those of you inclined, it also tells the story, but for the humans in the room, the posted messages really describe everything that happened in that transaction. Every single rule that fired gives us a message. Some of these messages have data, live data embedded in them, so you can see along the way how these values are being displayed and changed. And every message has a little piece of metadata here that tells us specifically which rule it was that fired to create that. So because we save all this stuff, we've got a record, we've got a really detailed audit log, a really detailed history of what our rules did for every single transaction. All right, do we need to stop? Yeah. Can you give me one more slide? Yeah, all right. I'm going to give you one more slide because even though I told you that clarity was our biggest concern, I know there are some of you out there thinking it's got to be performant, right? You told me that you don't replace these systems because they perform badly, and that's true. But Corticon is so fast. Corticon is so performant, so efficient in its compilation and its execution. It gives us the luxury of focusing on things like clarity and modularity and these other things that will help ensure the long-term or the longevity of our application. So to prove it to you, I want to show you a snapshot of some live production data. This is our long-term care application, which consists of 3 separate decision services of about 1,000 rules apiece. Within those rules, there are about 4 database queries on average, and each payload has about between 1 megabyte and 2 megabytes of data. Relatively large as cases go. We're using the REST API, and as you can see, our average transaction time is about 60 to 70 milliseconds. Fast enough that this is the least of our concerns for application performance. This is so fast, in fact, that we can spend our time worrying about organizing, writing clear rules, writing rule statements, all that kind of stuff, which is, in the end of the day, what's going to, prevent this application from becoming legacy before it's time. We, just as a quick side note, we've been using the REST interface now for a couple of years, and it really has been, my hat's off to Jim and his developers, because the REST interface has really changed the way that we implement Corticon. We used to really have to make a decision about whether performance or loose coupling flexibility of a service-oriented SOAP interface was more important. And if we wanted it performance, we had to go the way of Java Object Messaging, and if we wanted, loose coupling, we had to go away of SOAP. But REST gives us the best of both worlds. We no longer have to worry about that. REST is faster than both and more flexible than both. So if you have an implementation that's using SOAP or Java Object Messaging, I highly recommend giving the REST interface a look. In our own experience, it's about 5 to 7 times faster than the SOAP interface. So when it's that fast, you get to worry about these other elements of the implementation that, in the long run will determine its success. Okay, sorry I rushed through a couple of slides. I'm happy to stay up here for as long as you want and answer any questions. Otherwise, I will let you go to your next slide.